Hello everyone, today we will start the topic of thermodynamics. The first things which are included in the syllabus of thermodynamics chemistry part is the first law of thermodynamics. The first law of thermodynamics is a version of the law of conservation of energy which is adapted for thermodynamic systems. The law of conservation of energy states that the total energy of an isolated system is constant and energy can be transformed from one form to another, but can be neither created nor can it be destroyed. The first law is often formulated as delta U equals to Q minus W. So, it states that the internal energy delta U of a closed system, it is equals to the amount of heat, that is Q, supplied to the system minus the amount of work W done by the system on its surroundings. Now, what we want to know more about is delta U, which is the internal energy. The internal energy of a system is the energy which is contained in the system, excluding the kinetic energy of motion of the system as a whole, taken as a whole, and the potential energy of the system as a whole due to the external force fields on the system. The internal energy of a system can be changed by transfer of matter or heat or by doing work. The next topic which comes in the syllabus is enthalpy. Enthalpy is defined as H. The enthalpy of a homogeneous system is defined as H equals to U plus PV. H is equals to U plus PV. So, what is H here? H is the enthalpy of the system. U is the internal energy of the system. P is the pressure and V is the volume of the system. So, enthalpy is an extensive property. This means that for homogeneous system, the enthalpy is proportional to the size of the system. Remember, the two laws that we have studied till now is this law, internal energy delta U equals to Q heat minus W, that is the work done, and enthalpy, which says that total enthalpy H is equals to internal energy plus pressure into volume. The next topic which is included in the syllabus is heat capacity. The heat capacity or the thermal capacity is a measurable physical quantity which is equal to the ratio of the heat added to the object or may be removed from an object to the resulting temperature change. So, basically the unit of heat capacity is joule per Kelvin, the amount of heat received or removed from the system and with respect to the temperature change, resulting temperature change. The specific heat is a particular value of heat capacity. It measures the amount of heat which is needed to raise the temperature of 1 kilogram of mass by 1 Kelvin. So, specific heat is the amount of heat which is required to raise the temperature of 1 kilogram of mass by 1 Kelvin temperature. So, we know what is the specific heat and we know what is the heat capacity. Now, the other law which comes into the picture is Hess's law. Hess's law states that the total enthalpy change during the complete course of chemical reaction is the same whether the reaction is made in one step or in several steps. Hess's law states that the total enthalpy change during the complete course of chemical reaction is the same whether the reaction is made in one step or it is made in several different smaller steps. Hess's law is now understood as an expression of the principle of conservation of energy, which is also expressed as the first law of thermodynamics, and the fact that the enthalpy of a chemical process is independent of the path taken from the initial to the final state. So, basically a chemical reaction is a state dependent process. It does not depend upon the path which is taken to reach to the final state from the initial state. Again, I am repeating that Hess's law is the law which states that the total enthalpy change during the complete course of chemical reaction is the same whether the reaction is made in one step or it is made in several steps. Now, there are some particular enthalpies which we are going to talk about. There are many different kinds of enthalpies which are prevalent in the chemistry or physics background. So, we will talk about standard enthalpy of formation, we will talk about standard enthalpy of combustion, atomization, bond, etc. So, the standard enthalpy of formation is that it changes when the formation of 1 mole of a compound from its elements in their most stable state of aggregation, which is also known as the reference state. This is called standard molar enthalpy of formation. Standard mole enthalpy change for the formation of 1 mole of a compound from its ingredients or the elements in their most stable state of aggregation, also known as the reference states, is called the standard molar enthalpy of formation. Again I am repeating, standard enthalpy change for the formation of 1 mole of a compound, 1 mole of a compound from its elements in their most stable state of aggregation, also known as the reference states, is called standard molar enthalpy of formation. The symbol is delta F H naught. F H naught. This is standard molar enthalpy of formation. Another thing is standard molar enthalpy of combustion. So, this is defined as the enthalpy change per mole or per unit amount of a substance when it undergoes combustion and all the reactants and the products are at their standard state at the specified temperature. So, what is the standard enthalpy of combustion? Standard enthalpy of combustion is defined as the enthalpy change for 1 mole or per unit amount. See, in every case it is either 1 mole or per unit amount. For 1 mole it is basically preferred of a substance when it undergoes combustion and all the reactants and products are in their respective standard states at specified temperature. This is called standard enthalpy of combustion. There is another thing called standard enthalpy of atomization. Standard enthalpy of atomization is denoted as delta A H naught. Standard enthalpy or enthalpy of atomization. Enthalpy of atomization is the enthalpy change on breaking 1 mole of bond completely to obtain the atoms in the gaseous phase. If 1 mole of atom or 1 mole of bond is broken to obtain the atoms in their gas phase, that is the gaseous state, then the amount of enthalpy change will be called enthalpy of atomization. In case of diatomic molecules like dihydrogen or H2, the enthalpy of atomization is also the bond dissociation enthalpy, because there are only two atoms, right, in the dihydrogen molecule, H and H. So when we are breaking this, then the amount of enthalpy which is spent, that is equals to the bond dissociation energy, because the hydrogen bond is in between the two hydrogen atoms, the bond is breaking. Therefore, the enthalpy of atomization is also the bond dissociation enthalpy. In some cases, it is also same as the enthalpy of sublimation. What is the bond enthalpy? Delta bond enthalpy, that is delta bond bond enthalpy H naught. This is equals to also written as del R H. It is equals to the bond enthalpy of the reactant minus the bond enthalpy of the product. Summation of the bond enthalpy of the reactants minus summation bond enthalpy of the products. Okay. So what is the, we have studied standard enthalpy of formation, we have studied standard enthalpy of combustion, we have shown standard enthalpy of atomization, bond enthalpy, which is also defined as, which is actually statistically defined as summation of the bond enthalpy of the reactants minus summation of bond enthalpy of the products. Next is the enthalpy of solution. Enthalpy of solution is denoted as delta sol H O. Okay. So this is the solution enthalpy or enthalpy of solution. Enthalpy of solution of a substance is the enthalpy change when 1 mole of a solution of the solute dissolves in a specified amount of solvent. When 1 mole of a particular value or particular reactant disperses or rather dissolves in a specified amount of solvent, then the enthalpy change is known as the enthalpy of solution. Enthalpy of solution of a substance is the enthalpy change when 1 mole of that particular substance dissolves into a specified amount of solvent. The enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substance in an infinite amount of solvent when the interactions in between the ions or the solute molecules are negligible. Enthalpy of solution of a substance is the enthalpy change when 1 mole of it dissolves in a specified amount of solvent. The enthalpy of solution at infinite dilution is the enthalpy change observed when on dissolving after dissolving the substance in an infinite amount of solvent when the interactions in between the ions or solute molecules are negligible. So that's the first law part of thermodynamics, and in the next lecture we will talk about the second law of thermodynamics. Thank you.
Thank you for watching. Visit us at needbook.in.